Unit 1, Part 2 of 1.3. I'm going to do an example on rounding. So the question would say round 0.00683 to 2 decimals or 2 significant figures. And this example is a nice way to explain the difference between rounding to so many decimals as opposed to so many significant figures. Right, rounding to 2 decimals means we're going to first write 3 decimals. We're going to look at the third one, which is the one we're going to discard. All we want to see is it greater than or equal to 5 or smaller than? Well, it's greater than. That means when we write it to 2, the last man standing is 1 more. Now, with significant figures, you only start counting at the 6. So if we look back at this number, all these zeros in front are not significant figures. So if we write it first to 3, then we only start counting at the 6. So the 683 count as 3 significant figures. We can't just throw away the zeros. We know that they have a lot of meaning, but we only start counting as significant from the 6. The 3 that we discard is now smaller than 5, meaning when we drop it, the 8 won't get bigger. So when we write the answer, we still need to write the 0.00, but we end with a 6/8. There's 2 significant figures. Let's have a look at converting from one form to another. Remember that we said fractions and decimals are just 2 ways of writing the same thing. So if I have a decimal and I actually want to put it in fraction form, often when you have a decimal, you really don't have that much of a feeling for, shall we say, how much of the pizza you have, whereas a fraction shows that clearly. So let's say, for instance, we have 0.75 and we want to see what is that in terms of a fraction. If I have 0.75 of my pizza left, how much do I really have? The trick here is you first write it exactly as it is, but over 1. Then you say, if I want to get rid of the decimal point, it's got to jump to the end. So it's got to take 2 jumps if I want to make this a 75. For each jump, you add a 0 after the 1. Now you need to simplify, which means you've got to see what divides into both the numerator and denominator. In this case, 25 divides into both. So 25 into 75 is 3. 25 into 100 is 4. So 0.75, I've actually got 3/4 of my pizza left. Let's see if we had to go from a fraction to a decimal. So here your rule is divide the numerator by the denominator. I'm going to use exactly the same example that we've just done, but obviously just backwards. Now I'm not putting equal to. You've got to do a long division. So like that, 4 into 3. Well, we know 4 doesn't go into 3. But 3 has the same meaning as 3 point any number of zeros. So when I do that, I can now say 4 into 3 goes nothing. Keep your decimal point. Now look at this, but think of it as a 30. So below this line, we're now going to just ignore the decimal point. We've now done our point. It's in its place. So 4 into 30 goes 7 times. That's a 28. So we're literally doing 30 minus 28 leaves 2. Bring down the next 0. 4 into 20 goes 5 times. 5 times 4 is 20. If you subtract that, you get nothing. So now I know I'm done. So now I know that 3/4 is the same as 0.75. I want to do another example here. Show you one that gives you a repeating decimal as an answer. So 9 into 2. We know that can't, so we put 0.0. I just always put 2 zeros, but you can add as many as you like. It's just to get to the answer. Right, 9 into 2 goes nothing. Put your decimal point. Now we don't think of this as a 2 anymore. We think of it as a 20. 9 into 20 goes 2 times. 2 times 9 is 18. Subtract that. 20 minus 18 is 2. Bring down the 0. See what's happening? 9 into 20 is again 2. 2 times 9 is again 18. Now, if you added more zeros, you would just get the same thing. So can you see it's going to keep going forever? So we're going to have 0.2222 going on forever. Right. If it repeats, like in this case, there's a short way of writing it. You just put 1, 2 with a little dot at the top. That means the 2 goes on forever. Lastly, as far as operations, remember what operations were? Plus, minus, times, and divide. I am simply going to say, here it's fine to use your calculator. Remember with the fractions, we had to know how to do these operations because once we get to algebra, it's important to know the rules. However, with the decimals, you don't really need those rules. You need the fraction rules for algebra. So as far as I'm concerned, we're going to not worry about all these operations. We'll just use our calculators for that.